A typical thermal fluid system is comprised of four main components. 1. Thermal fluid heater. 2. Thermal fluid circulating pump. 3. Deaerator. 4. Expansion tank. End users: fuel oil heaters, tank heaters, freshwater generator, centrifugal separator heaters, economizer, etc. Thermal fluid heater. A single heater can heat multiple pieces of equipment connected in one or more thermal fluid circuits. Moreover, heating of each piece of equipment can be controlled independently by valves that modulate the flow of the hot fluid through the equipment. Heaters can be single-pass or two-pass helical coils. Two-pass helical coils are the most popular. They burn a variety of fuels and have high thermal efficiencies that conserve fuel. The heaters can be either vertical or horizontal. A significant advantage of vertical heaters is their small footprint, so they can fit into small ground areas. Heaters fired by the following fuels. 1. Gaseous fuels, natural gas, liquefied petroleum gas, etc. 2. Liquid fuels, light diesel oils, heavy oils, etc. 3. Solid fuels, wood, coal, coke, rice husk, etc. 4. Electric heaters. Thermal fluid circulating pump. There are two types of pumps used in a hot oil system. There is a gear pump, not as commonly used, and centrifugal pump, the preferred type of pump because it can allow higher flow rates to ensure that there is turbulent flow through the heater. Pumps may be air-cooled or water-cooled. Hooking the pump up to a battery or generator backup system, to make sure the system flow is maintained, during an electrical outage or during rapid shutdown. Deaerator. Water or any fluid which is used as a medium for heat transfer, generally contains oxygen and other non-condensable gases in it. These gases dissolved in a fluid acts as an insulation to heat transfer. Due to the presence of these gases in the fluid, heat transfer rates from fuel to fluid is generally reduced, which in turn will increase the fuel required for heating, thereby decreasing the efficiency. The deaerator is used to store both cold and hot fluid, in order to remove dissolved air or vapor from the fluid. Deaerator protects the system from the effects of corrosive gases. It accomplishes this by reducing the concentration of dissolved oxygen and carbon dioxide, to a level where corrosion is minimized. Expansion tank. Fluid selection, system volume and operating temperature, will impact expansion tank size. Depending on the fluid selection and operating parameters, systems may be open or closed to the atmosphere. Closed systems may be pressurized with an inert gas blanket. In certain application of thermal fluid heating design, combines the operation of the expansion, deaerator, and thermal buffer tank, known as deaerator-cum-expansion tank, is installed to 1. Requiring less space, it comes with a buffer vessel, to prevent cooling of hot oil coming from the process. 2. The tangential thermic fluid entry in the deaerator, ensures optimal deaeration. According to design, there are two types of thermal fluid heating system. 1. Single-line heating system. 2. Multi-line heating system.
The single-line heater has pipe connections for a single external circuit. It has a single pump that circulates the oil through the heater coil and through the external circuit. So a single pipeline circulates the oil from the outlet of the heater to all components connected in series with each other. But a number of components in series with each other create a lot of resistance to flow. This resistance dramatically slows down how fast the hot oil flows through the components and returns to the heater, and it noticeably increases the time needed to heat the components. Moreover, the heater will shut down if oil flowing through its coils is too slow to convey the amount of heat being generated. A multi-line heater with side pumps overcomes those drawbacks. However, it requires the additional pumps, which add to the cost of the system. The multi-line heater has a circulation pump and manifold. The circulation pump serves solely to recirculate the oil through the heater coil. This assures optimal flow of oil through the coil in the heater regardless of flow through other components in the system. This prevents overheating the coil and extends its life. The manifold has outlets and returns for multiple circuits. It can have 2 to 4 outlets and returns. Each outlet serves as the hot oil source for an independent circuit with its own side pump. Each side pump circulates the oil through a circuit with less resistance because it has fewer components. After the oil transfers its heat to the components, it returns to the manifold. There, it's mixed with the hot oil flowing out of the heater coil and cooler oil returning from other circuits. The major benefit of multiple circuits is faster oil flow to all components, noticeably reducing time to heat the components. Moreover, heater shutdowns are avoided because the circulation pump maintains optimum flow through the heater coil.
Advantages of multi-line thermal fluid system. 1. Prevent overheating the heater coils or tubes, and extend the heater coils or tubes' service life. 2. Overcome the flow resistance of the heating fluid in the system. 3. Reduce the shutdown due to low-pressure oil flow to the end users. 4. Easier for the plant expansion.